Hey guys, it's Rez. All right, so I do not have a number for which standard this goes with, but it's kind of an in between the winds that we just looked at and what's coming next with El Nino and La Nina patterns. You have to kind of understand what's going on with the ocean first. So we're going to talk about surface ocean currents and deep ocean currents. So first of all, something to understand, right, is that we know that as winds sort of blow over the water, they're going to move the water. And along with the Coriolis effect and where the continents are located, we basically end up with these big gyres. They're called. So we call ocean gyres, or these big circular surface ocean currents. Now, like we learned with the Coriolis effect, right? Things that are in the northern hemisphere are going to rotate clockwise. So all of our ocean gyres, our big circles up here, rotate clockwise. And again, it's based off of, if you go back and look at the winds that we drew in our activity 3, the winds themselves all play into this model you see of these ocean gyres, right? Southern hemisphere ocean gyres are going to rotate counterclockwise. They have on this image, right, the red and the blue arrows to show you warm versus cool ocean currents, which we'll talk about in a little bit. Right now we're going to talk about that. So just like winds sort of distribute heat around the world, the oceans do the same thing, right? Because again, solar insolation is strongest at the equator, so the sun is going to heat up the water more at the equator than the poles, right? Just like what happens with the air. So basically these warm water currents, if you look, they're all starting at that equator and they're moving heat away from the equator up to the poles. When these pass by land, those areas typically have warmer, wetter climates. Okay, so look at the entire east coast of the United States. We have that really warm ocean current that moves by us that helps kind of regulate our temperatures. Now, cold water currents are coming usually from like the polar regions up towards the equator. And again, as those go by land, colder, drier climates are going to be present there. Okay. Now, I think this is just kind of a fascinating fact. So we were just talking about how air, right? When air is warm, it's less dense, right? Water is sort of the same thing. And when water warms, it actually expands. So if you think about all the warm water along the equator, it is actually expanded to a point where it's about 3 inches higher at the equator than the mid latitudes. So literally, a lot of this water moving away from the equator is sort of just running downhill in a weird sort of way, right? Kind of a neat way to think about that. All right. So one of the things that we see happening with these gyres is that water gets pushed towards the center, right? As they spin, things sort of get contained. And we end up seeing garbage patches up here in our oceans. And you may have heard of these. The Great Pacific Garbage Patch is kind of the most well-known one, but it is not the only one. This is like staggering data over here, right? But by most estimates, it's about 3 times the size of France. So this is massive. It's made mostly of fishing nets and fishing gear that's been discarded, but there's also lots and lots and lots of plastic. Between, they estimate 1.1 and 3.6 trillion pieces of plastic. Now, plastic doesn't ever truly go away. So some of these bigger pieces are going to get eaten by living things, but a lot of the other ones are going to sort of get degraded by the ocean's movement over time. And eventually will just become microplastics, which are not good either. Anyways, on this, plastic will account for 74% of the diet of sea turtles that enter that particular area. And that's just sea turtles, right? Anything else that would kind of be eating stuff out of the water is going to eat some of this plastic too. All right. So this is something we did in class. I'm going to skip this. But something I wanted to talk about, an interesting little phenomena with surface ocean currents. So if you imagine wind is blowing across the ocean. Now you can actually model this. If you put your finger in some water and sort of move it quickly, you will actually see this phenomenon happen. So there's friction as that happens. And basically what it causes the water to do, or the surface current to do, is to move at a 45-degree angle to the wind direction. And as you can see, that sort of angle increases as you go down because there's more friction that it's dealing with. So typically what we say is that if you kind of look at all of those, because that spiral continues, we call this the Ekman spiral, that the net flow of water is going to be at a 90-degree direction to the wind. So if that wind is blowing north, and we were in the northern hemisphere, right, our net flow of water is going to be towards the east. If we were in the southern hemisphere, it would be the opposite, right? Because it's going to push to the left because of that Coriolis effect. Now, this becomes important when we start to think about upwelling and downwelling. So, if you think about the ocean, the deeper waters are much more nutrient rich than the surface waters. So, some of these currents, what they'll actually sort of do is they're pulling surface water away from the coast, and it allows some of that deep ocean water to move up to replace it. As it does that, it brings nutrients with it. So, areas where we have this upwelling from this deep water, we have a lot of nutrients that come with it. Those tend to be really productive areas. We get a lot of good plant life, we get a lot of good marine life in there. A lot of times we find these upwelling areas, we have fishing communities because there's a ton to fish. So we're going to do this in class. I don't know when you're watching this, but we're going to look at where there's upwellings and where these productive areas are. Now, we also need to talk a little bit about deep ocean currents, and I won't go too much into this. I'd asked this question in class at some point. I don't want to answer now in case you haven't. Well, I'm going to answer anyways. But so deep water circulation is driven by the salinity of the ocean and the temperature of the water. Okay. So if we're looking at which is more dense, colder water is more dense, just like in the air. Okay. Oh, and we kind of could watch this, but we're not going to. Oh, no, it's playing. There we go. Saltier air is also more dense. So basically, as warm water moves to the poles, evaporation is going to occur. It's leaving behind more salt. Salt is denser, right? As it's moving north, it's also becoming colder. Colder water is denser. So that increase in density basically causes this cold, really salty water to sink down into the deep ocean. Okay. As it sinks down into the deep ocean, it's going to continue to kind of travel along the floor, and that will kind of continue traveling, and it will eventually rise back up to the surface. And again, it's basically like a big conveyor belt. So if you look at these big kind of global patterns, right, you can see the deep ocean currents are in blue, the shallow warm ocean currents are in red. And these are different than the surface currents. This is basically a big, huge conveyor belt that just kind of runs. Now, one of the things that kind of gets brought up a lot, if you've ever seen The Day After Tomorrow, the premise is that basically we have these crazy weather phenomena happening, like the world's ending, whatever. Could that ever happen? Probably not. That's not scientifically accurate. But the premise of The Day After Tomorrow is that basically the surface waters warm so much along the poles that we never get that water cooling enough to actually sink. And that because that happens, this whole current sort of stops. It's like the conveyor belt gets stuck. And that, if that were to happen, would have really drastic effects on our environments. Like that part of it is possible, right? Because you think about it, if you stop moving around the warm and cold water, everywhere that that temperature is regulated on land by those cold and warm currents would be affected by that. One of the big ones is like England. So England, if you look on the map here, is actually really far north, but it has a pretty mild climate. And it's because of that warm ocean current. Now, if that didn't run, if that wasn't running, England would really kind of look where it is in relation to Canada. Like it's like northern Canada. Their climate would change drastically. So just kind of something interesting to think about there. All right, that's all I got for ocean currents. We're going to come back and talk El Nino and La Nina in the next video. Until then, happy learning.